Well, we have question 1.1 that says solve for x. And now I'm going to do question 1.1.1. Right here, question 1.1.1. It is given that x squared plus 5x minus 6 is equal to 0. Now, so this is a type of a quadratic equation. So our trinomial, we can solve this by factorization, okay? By factorization. By factorization is when we change this trinomial in terms of a product of two binomial, and then of something like a times b equal to 0, and then we know that this would be equal to 0, a equal to 0, or b equal to 0. This is one of the properties of multiplication. That's what we're going to do. Because we have like x squared plus 5x minus 6 is equal to 0, we're going to look at the leading coefficients of the equation. The leading coefficient is the coefficient of x squared, okay? It is just 1. So the moment that we have like the coefficient being 1, the leading coefficient being 1, we can just write x in the bracket like this, okay? Equal to 0. Then we're going to consider the constant term, which is -6. Now I want to write here, excuse me, the constant term is -6. -6. Now I'm going to list the factors of 6, preferably in ascending order. The factors of 6 are like 1 and 6, 2 and 3. Now in the list of the factors of 6, I said they are 1 and 6 because 1 times 6 makes 6, 2 and 3 because 2 and 3 times 2 times 3 makes 6. Now in the list of the factors of 6, there must be exactly one couple which will make a sum equal to coefficients of the middle term, so the coefficient of x, which is positive 5. Now let's see which couple will make a sum equal to positive 5. Okay, we can see that if we do positive 2 and positive 3, of course they will make positive 5. They can sum up to positive 5. But positive 2 times positive 3 don't make -6, okay? They don't make -6. So it's not the right couple to select. So we have left with 1 and 6. Yes, we can get positive 5 here if we do -1 and plus 6, and they can also make -6 because -1 times positive 6 makes -6. That's -6. No, those are the values we're going to place in the brackets here, and then we can put them in different order. It won't matter. Like I can write over here positive 6 and then -1. Doesn't matter. And then this will be equal to x plus 6 equal to 0, following the law of multiplication listed over here. Okay, so we have like x plus 6 equal to 0, or x minus 1 equal to 0, which means x is equal to -6. Okay, or x equal to 1. Okay, we can also solve the same problem by using the quadratic formula. Okay, I'm gonna write here. Okay, because of space, let's move this way. Using the quadratic formula is given by x equal to minus b plus minus square root of b squared minus 4ac all over 2a, while the quadratic equation itself is ax squared plus bx plus c equal to 0. Now we are going to identify the value of a, b, and c. So a, b, and c from the equation. Okay, from the equation is x squared plus 5x minus 6. So we can see that a is 1, okay, b is 5, and then c is 6, right? Not exactly, it's -6, okay, because we're going to take the number together with the signs. Now we can sub in this in the calculator. That will make -b plus minus square root of b squared minus 4ac, okay, or over 2a. Now, on a substitute here the values of a, b, and c. So we have like negative b is 5. Okay, so we have like 5 squared minus 4a, which is 1, and then c is negative 6 over 2a, 1. Now we can use a calculator to sub in these values. Okay, so on sub in the values there, so we have like 5. We get the value of b minus so it's going to be b squared, so 5 squared, so 5 squared, okay, minus 4a, which is just 1, and then c is equal to negative 6, and then over 2a. A has the value of a has the value of 1. Okay, so we press enter. You see, we have the two solutions that we have there. X is equal to negative 6, or x will be equal to, when I work out the other solution, then we're just gonna change over here. We're just gonna work out, put the positive there, positive over here, plus, and then this is equal to 1. So x is equal to 6, or x is equal to 1. Okay, we can also solve the same problem by using completing the square, but I want to use completing the square in question 1.1, but I will do that in question 1.1.2. Thank you.